All right, what's up, guys? This is Mr. Fabella. This is going to be starting off Chapter 7, which covers classifying angles and identifying vertical angles and also solving for angles. But the essential question here is how does geometry help us describe real world objects? Looking around in your room, when the walls meet, what angle is that? If you're going to throw a ball up into the air, what angle you're throwing that up into the air at? If you're playing pool or bouncing a ball on the ground, what is that angle that's bouncing up on that? And other things like that as well. So we're going to use facts about supplementary, complementary, vertical, and adjacent angles in a multi-step problem to write and solve simple equations for an unknown angle in a figure. So tomorrow or the next lesson will be supplementary and complementary, but today we're really focusing on vertical and adjacent angles, and we're going to find unknown angles. Okay, so what we're going to learn today, name and identify angles, and find a missing angle measure. So there we have an angle right there. I'm naming it B, A, and C. So let's start about the angle parts. First we have the vertex. So the vertex is going to be named as point A. The vertex is where two lines meet in that case. Right there, that's going to be our vertex at point A. So next, the sides. We're going to have sides AB, and I forgot the little arrow there, and AC. So here, if we're talking about this specific angle, those are actually rays. They start at one point, and they go off forever in these directions. So that's why there are three ways to name this specific angle here. One way, the obvious one, would be angle BAC. The other would be CAB. So we have BAC going this way, and then we can name it CAB going this way. We can also name it just angle A. This is just an angle, it's not a triangle. There's no other extra stuff there. So angle A. And a fourth way, which isn't there, but sometimes you'll see that there's maybe a number here, like 4. So you could also say it's angle 4. One thing that you have to be careful of is naming it angle A or angle 4 is completely fine the way it looks like right now. But if you had something like this, like a whole bunch of angles here, or two intersecting lines, and let's say this was A, and this was B, and this was C, and this is D and E. If I said angle A and I really wanted to talk about, let's say, this angle right here, A could be anything. A could be this angle, it could be this angle, it could be this angle. So you can't just say angle A. In this case, if I'm talking about this angle right here, it would have to be angle BAD or angle DAB, just not angle A. Now, defining an angle, it is formed at the intersection of two rays or line segments. So in this case, if I left it without the arrows here, that could have been fine as well. But we're just going to use the arrows there. We have the types of angles, and a lot of this will be review for you guys. So right here, we have something called an acute angle. That's defined by an angle that measures less than 90 degrees. We have here, so that you could just assume what that is. But if you're looking at your textbook, you have to look for a little square right there. That is a right angle. And a right angle is something that measures exactly 90 degrees. So that's what you're going to see a lot in architecture everywhere you look around your house. Usually you're going to see, the floor is going to meet the walls at 90 degrees, and most of your walls will meet each other at 90-degree angles. So, but just be careful. Either somewhere it's going to say it's right, or you have to have this symbol right there, or it'll have to say 90 degrees somewhere, or you'll have to figure out that it's 90 degrees. Because if there's nothing there and I drew an angle like that, that maybe kind of looks like a 90-degree angle, but it could be 89.5 degrees, or it could be 90.2 degrees. Conversely, if you really look hard at that, that kind of looks acute to me, but if I put a little box there, then that's saying that I want that to be 90 degrees. So you have to take it that it's 90 degrees. All right, after that, acute right, then that's right, it's obtuse. And obtuse is an angle that measures more than 90 degrees, but less than 180. So a lot of times you're saying, oh, it's more than 90 degrees. Technically, yes, but when we're talking about this, we're going to say it's more than 90 degrees, less than 180, because of our last one, which is a straight angle. A straight angle is an angle that measures exactly 180 degrees. And that's all the angles we're going to talk about right now. We're not going to talk about anything more than 180 degrees. Because if I did this, that looks like an acute angle. But maybe I'll say, no, I'm measuring this angle over here. That's not exactly considered obtuse, because that's going to be like, I don't know, probably like 330 degrees or so. That's probably 330 degrees. So we would just say that's an acute angle, and leave it at that. Some vocabulary for this math class here is this symbol right there is for angle. And the one thing here is that when you're naming an angle, like angle A, B, C, that's what the symbol is going to look like. Don't make it look like the angle you're naming. So, for example, if I had angle, you don't have to name it X, Y, Z. It's going to look a little weird. If it was a right angle, it might look exactly like an L. It would just be named angle X, Y, Z, and not this way. And the other symbol here is going to be congruent. It's another symbol of equality. If you remember from before, you have the equal sign, and you have congruent. That means same size, same shape, as opposed to similar, which is just this. This is similar, and that's just the same shape. So similar is like this triangle is similar to this triangle. It's the same shape, and we'll talk about that a little bit more later on. But congruent means same size, same shape. If you're saying the two angles are congruent, if one is 55 degrees, the other angle is also 55 degrees. All right. And another piece of vocabulary here is adjacent. So when two angles are adjacent, basically they're right next to each other. So they share a common vertex, a common side, and they do not overlap. So angle 1 and 2, angle 1 and angle 2, angle 2 and 3, 3 and 4, and 4 and 1. They're right next to each other. They are considered adjacent in this model here. Now vertical, we're going to prove this a little bit. But two angles are vertical if they are opposite angles formed by the intersection of two lines. So sometimes there will be more lines, but I'll show you how to kind of work through that. So in this case, 1 and 3, and then we have 4 and 2. Those are vertical angles, and they are actually congruent. And we'll go ahead and prove that right now, because yeah, they look congruent, but it's actually pretty neat the way that this gets figured out. So, vertical angles. They're formed by intersecting lines. So we have two intersecting lines right there. Opposite angles, or vertical angles, are always congruent. These two red lines mean that those two angles are congruent, and then double lines means that those two are congruent. And adjacent angles are always supplementary. We kind of knew that. Adjacent angles when two intersecting lines. They're always supplementary in this case. So we're right next to each other. They're going to be supplementary. If you forgot what supplementary means, that means they add up to 180 degrees. So right here, we have a 30-degree angle. And if you have two intersecting lines and you have the measure of one angle, you can find the measure of the other three angles pretty easily. And let's say we didn't even know that opposite angles are always congruent. Well, what we do know is that a straight line, this is a straight line, is 180 degrees, right? So if I know that that's 180 degrees, I can ignore this part of the angle. This is a straight line. One angle is 30 degrees. The other angle of B is, I don't know, but I know that both of them added up equal 180 degrees. So right here, you have one angle that's 30 degrees, and they'd like to know what the other three angles are going to be. And let's just look at what we just learned about vertical angles, and then we can worry about the rest in a little bit. So first of all, it says right here, vertical angles are always congruent. That means the same size, same shape. So if this angle is 30 degrees, the vertical angle to it, the opposite angle, would be A. So that's going to be 30 degrees as well. All right. So the other angles, that might be a little hard to figure out, but you can actually notice here, I can kind of look at that. That is a straight line. That's a straight angle. And it says supplementary, but even without learning supplementary yet, we know that a straight angle is equal to 180 degrees. So if 30 degrees plus the measure of angle B, those two together, this right here, that should equal 180 degrees. And this is going straight back to solving equations. If I want to know the measure of angle B, 30 is being added to it. I'm going to do the opposite of that. I'm going to subtract 30. So the measure of angle B is going to be 150 degrees. So this is 150 degrees. And I'll write it over here. And I'm writing it in the diagram because now you can see I don't have to do that same kind of math over here. I don't have to go and look at, okay, this angle right here, these two angles, they make 180, and I'm going to have to do a whole bunch of other math there, write an equation or anything. I could just see, okay, if this is 150 degrees, that means the vertical angle, the angle opposite to that, should also be 150 degrees, and that's angle C. So this is 150 degrees. All right. So right here, we have two examples, and why don't you try to solve for the other three angles on both of these? And then you can pause it for a little bit, try to figure that out, and okay. So we have 125 degrees on this side, and you have X, Y, and Z. I'm actually going to take the long way to do this because I'd like to actually prove why vertical angles are going to be congruent. You have 125 degrees here. So if I wanted to find the measure of angle X, Y, and Z, if I wanted to find the measure of angle X, you saw that right there. These two angles together should equal 180 degrees. Okay, so if I wanted to solve that, I would say X plus 125 will equal 180 degrees. All right, so if I subtracted 125, I should have X to equal 55 degrees. That's the only kind of subtraction I needed to do. After that, I could use my rules of vertical angles, because I know if X is 55 degrees, then I know, let's see, well, let's look at Y first. Y is opposite 125, so that means Y has to also be 125 degrees. And then Z is opposite 55 degrees, so that means Z has to also be 55 degrees. And if you didn't want to do that, you could also done the same thing that we did here. you could have said z plus 125 equals 180, but that's kind of a waste of time if you already know how to use vertical angles. And for number 2, notice here it was named differently. The angles are not named in the middle, so I had to actually use the 3 letters to name these angles. But ABC, that's talking about this angle right here. Same thing as before. This is 43 degrees plus the angle, measure of angle ABC, which is right here, equals 180. Those two things together should equal 180. So if I subtract 43 from both sides, I get 137 degrees. So the measure of angle ABC will be 137 degrees. And I'll write that in here so I can kind of visualize it. So now angle CBD, that is opposite of 43 degrees. So those are opposite. That means this is also 43 degrees because vertical angles are congruent. And then same thing for B. This is B. Same thing for angle EBD. So ABC is 137. That means EBD has to also be 137 degrees because they are vertical angles. And that's about it for naming angles and finding missing angle measures using vertical angles. All right. See you next time. Okay, so I just realized after the last video I did, I said I was going to prove why vertical angles are congruent, but I never really did. So I'll do it in like kind of 2 ways. So let's make it as simple as possible and just draw 2 intersecting lines like that. Okay, and I will just name these angle 1, 2, 3, and 4. So from what we already learned, angle 1 and 3 are supposed to be vertical and they're supposed to be congruent, but we're going to go ahead and try to prove that right now. So let's just say that angle 1 is 60 degrees, right? One way to kind of show it, not exactly prove it, is I will go with angle 1 and 2. Angle 1 and 2 are considered, they're called a linear pair because this angle right here and this angle right here, they equal 180 degrees. So if I say that 60 plus the measure of angle 2 equals 180, that's going to be correct. So if I work that out, I get the measure of angle 2 is equal to 120 degrees. So I also know that another linear pair would be angle 2 and angle 3 right there. So with angle 2 and angle 3, I could say I know that angle 2 is 120 degrees plus the measure of angle 3, that's a linear pair, so it should equal 180 degrees. So if I subtract 120 from both sides, I have the measure of angle 3 is going to be equal to 60 degrees. So back here, this is also 60 degrees. I don't have to, but let's say I really wanted to. I could go even further and go, okay, angle 3 and angle 4. Angle 3 and angle 4 right there. Those together, angle 3 is 60 degrees, plus the measure of angle 4. Both of them together, that's a linear pair. That's going to equal 180 degrees. So do the same thing. Subtract 60 from both sides. I have the measure of angle 4 is equal to 120. And there we go. We just showed angle 1 and angle 3 are congruent, and angle 2 and angle 4 are also congruent. So that's doing it the long way without using the rule that vertical angles are congruent, just by using the fact that a linear pair, 2 angles that make a straight line, equal 180. So there you go. So because I said I would prove it, I feel like I'd be lying or something if I didn't actually prove it, because this is just a proof kind of by example that shows that 60 equals 60. So you can stop the video here if you want to. You don't have to really prove this. This is something I taught in geometry. This is like a very simple type of proof. But let's take a look at another pair of angles here. I'll do the same thing, and I will name the angles the same way. Angle 1, 2, 3. I don't even need angle 4, because what I want to try to prove is that angle 1 is congruent to angle 3. So they're opposite each other. By definition, they're vertical. I want to prove that they are actually congruent. First, the diagram that's given, right? And I'm going to say angle 1 and angle 2 are a linear pair. That means those two angles make a straight line. All right, so that's kind of given from the diagram. And they're also supplementary, so they would equal 180 degrees. So I can say that the measure of angle 1 plus the measure of angle 2 equals 180. So see, the m there means the measure, so I'm talking about the actual degree measure, equals 180 degrees. Okay, 3. Angle 2 and angle 3 are also a linear pair. That's seen from the diagram as well. And if they're a linear pair, they're supplementary. They also equal 180 degrees. Their measure of angle 2 plus the measure of angle 3 equals 180 degrees. Okay, so now we have these two statements right here. Here and right here. And this is where a little bit more algebra comes into play, because if you notice, they both equal 180 degrees. So if they both equal 180 degrees, I can also say that the left side, with substitution, that the measure of angle 1 plus the measure of angle 2 equals, so this side equals this. So the measure of angle 2 plus the measure of angle 3. Because if they both equal 180, they both would equal each other. Okay? And from here, we can just subtract the measure of angle 2 from both sides. I could say, hey, there's a measure of angle 2 on both sides. I'm going to say minus the measure of angle 2 minus the measure of angle 2. Do that. The measure of angle 1 is equal to the measure of angle 3, which means that angle 1 is congruent to angle 3. And back to our diagram here, that shows that angle 1 is congruent to angle 3, and they are vertical angles. All right, and I could do the same thing for angle 2 and the angle 4 that I didn't mention, but that's just a little something extra if you wanted to see what a kind of a proof looks like, a very simplified proof. All right, so until next time, thanks.